Hello and welcome to this Innova Systems webinar on design tables. Design tables are functionality within SolidWorks which helps you create and control configurations, change sizes, change configurations of components, change whether features are suppressed or not suppressed. In this webinar, I'm going to be talking almost exclusively about Excel-based design tables. We do also have something called configure feature tables, and at the end of the webinar I will give you a couple of videos which will tell you how to use those, but for this webinar Excel-based design tables are the way to go. So I'm going to jump into SolidWorks, and here we've got a very complicated component which consists of 3 dimensions. We've got 150, 100 and a 10. Now if I want to create a design table, we go Insert, Tables, Design Table, and I've got 3 options of where I'm going to create it from. The first one is blank, does exactly what it says on the tin. If you're used to creating your own, then you can start putting stuff in, putting in variables and so on. Generally though, I'd advise the auto create feature, which will give me a list of dimensions in my model and ask me which ones I want to bring in. And finally we've got from file, and this is where you load in an external Excel table and say use that, it's already been correctly configured, use that to generate my configurations. And you can also link them together, but I'll be discussing this a little bit more later. We then have edit control, which says, do I allow somebody to edit something that's controlled in my design table inside the SolidWorks graphics area, or do I insist that they go into the design table in order to actually make those edits? There's pros and cons to both ways, as we'll see as we go through. And then finally, do you want SolidWorks to tell you when stuff has changed or when stuff's going to change and needs updating, and allow you to bring that extra information in? And I'm going to leave all of those on at the moment. So we'll hit the tick. So the first thing it does is sort of create an Excel file in the background within the SolidWorks file. Then it's going to bring up this box that says which dimensions do I actually want to include. Now I've got D1, width and boss extrude 1, and I'm going to include all of them. Use the control key to select more than one, and I hit OK. So we've now got our design table where I've got the default configuration, which is this row, and any other configurations will go in the further rows. And at the top I've got my variable names. You do need to be very careful with your syntax, but we'll see more of that later. So D1 and width. What I've done for the width dimension is actually rename it prior to starting the design table, so I know which one's which. This can be really helpful, particularly if you've got a much bigger assembly and knowing what it is you're controlling, or which dimensions you want to bring in the first place. So let's create some new configurations. I'm not being very original with the names, and I'm going to make this one double size. And let's do a half size one as well. So we can see all I'm doing is filling in the values against the relative cells. I do need to fill in all the values. If I just make that wider so we can see the configuration names, and then I'm going to come out and let it generate all of those names. So it's going to tell me it's going to create 2 new configurations, new configuration and half size. We hit OK to that. And if we go to configurations tab, we can now see here's my design table, and here are the configurations that have been generated. So if I double click on half size, it will show it up. There we go, it gets smaller. And we also notice that the hyphen here has turned to a tick. These symbols are new in 2013. The tick means that SolidWorks has generated the graphical data for that configuration. A hyphen means it only has the sort of geometric information. It hasn't mathematical geometric information. It hasn't actually created the graphical information yet. If you've got a tick, it means the configuration opens up quicker. I won't really be able to see it with this model because it's very simple, but certainly on bigger models you'll see it. If it hasn't got a tick, it needs to generate the graphical data before it can show anything to you, so it takes a bit longer. The more ticks you have, the bigger the file size is. So if what you wanted was to send this file to somebody else, but you want to make the file nice and small for emailing, what you can do is you can actually remove that graphical data of everything except the active configuration by right-clicking at the top, going to Rebuild Save, and choosing Remove Mark and Purge Data for all configurations. If I hit that, we notice the default tick disappears. It's then just a question of the next person opening it up and rebuilding the configurations. If, however, you are sending this to somebody who's got 2012 and is using the backwards compatibility functionality to open it in 2012 SP5, then they can only open configurations that are ticked when it leaves 2013. So just be aware of that if you're using that functionality. So we've now got our different configurations, and we've jumped backwards and forwards. If what I wanted to do was make my life a little bit easier, not just have width showing a dimension name, but also have height showing a dimension name, I can come into the dimension. It's going to warn me that I'm changing stuff, and it's going to need to update it in the table as well. And I can change the name, and I can just change this to height if I can spell it. Hit the tick. Again, it's warning me that it's going to update the design table. And then when I come back into the design table, give it 2 seconds to have a bit of a think about it. I don't want to bring any of these items in. You can see it's updated D1 to height. If you've done them first, you've done them first. If you do them afterwards, do them afterwards. What I recommend you don't do, though, is edit this value, or try and edit this value while you've got the design table open. Things get very confused. So don't do that. So that's a very simple design table. What we're going to do is we're going to jump into another file and have a look at some other things we can do with it. So here we are, we've got a sheet metal item. You can control sheet metal items just as easily as you control other items. And this already has a design table in it. So let's go and have a look at that design table. And I don't want to bring any extra information in at the moment. So we've got here a set of sort of standard properties. The first property is at D2 at sketch, is at actually the K factor. The second one is the thickness, as it says. The third one is my bend radii, and then I've got some dimensions that relate to my base flange, which is the back panel, the front panel, and the base panel. Now, I might want to include dimensions for these items so that they go and match the height. So I can double click on the feature, and then I can just click on each dimension to bring it in. Again, making sure that this is the cell that is selected, otherwise it won't populate it. It's also, because I double clicked on the feature, brought in a suppressed state for that feature, which I'm going to get rid of. Now that's very nice, but if, for example, I decided to change this value, so let's make this one 85 and this one 45, and then I rebuild, so if I come out of that, we can see that these side panels have not kept up with the front and back panel, so that it all looks a bit strange. So what I can do is I can actually put formulae into my Excel table to make sure that that happens. So if we open that back up again, I don't want any of that. What I'm going to do is I'm going to say that this equals this height minus the thickness, which I happen to know works out to the right value. So if we do that, hit return, it's now coming in 83, and then I can do exactly the same for the next dimension as well. Oh, choosing the right cell, and we can repeat this for the other ones. In fact, this time we can cheat, because we can just choose the previously calculated cell, so it just makes life very easy. Now what that means is when we come out, my side panels will match my front and back, whatever I do. Now that equation could easily exist within SolidWorks, and really it doesn't matter whether it exists in SolidWorks or whether it exists in the design table. It just depends where you like to have your dimensions, whether you want everything on one screen, and some people feel happier creating equations in Excel because it's a slightly more familiar interface. Now, there are also equations you can do in Excel which you cannot do in SolidWorks. So for example, this has got an equation which calculates the bend radius dependent on the thickness. So for this particular company, at X thickness you must have Y bend radius, and as you change the thickness, the bend radius needs to update. So if I change this from 2 to say 8, we can see that the thickness automatically the bend radius automatically updates, and this is done using a VLOOKUP. So it checks this value, checks it against a table, and then returns the appropriate item. Now this VLOOKUP table actually exists on sheet 2. So there we are, there's my relative thicknesses and their approximate bend radii. Now although I've done it from a different sheet, this could easily happen from a completely different Excel file. So if you have standard sets of data, be they cost, be they bend radius, be they particular sizes, you can actually go and reference those additional Excel files which are on your company servers in order to pull items through onto your Excel sheet. So this is something you wouldn't be able to do in SolidWorks, but is very useful, particularly for sheet metal users. Now, the other advantage is, as I've changed this, we also can see that these values have updated. So when I come out of my design table, we'll see everything rebuild, the thickness increase, but the side panels still match up with the front and back. So design tables become really handy for controlling items and putting some more complicated equations in. Something I haven't mentioned is you might find this little window quite hard to use. It's not very big, and you can accidentally click in the background, which makes everything disappear. Now, we've also got the option, if I come out of that, to open it in a separate window. So if I choose Edit Table, a new window, this loads up a separate Excel window and then loads the table into it. What's nice is in 2013, it also maximizes the window and the table. Previously, the table would be the same size as the little window you saw in the SolidWorks background, and it didn't make use of the full space. So now that does full size. If we come out of that, what we'll now do is jump into another part so that we can see some other equations. So here we are, we've got a yellow disk, it's got several suppressed features, and it's already got a design table. So if we load this up, I'm going to load it up within SolidWorks. So at the moment, we've got several configurations. We've got default, smile and frown. We've got a whole load of some dimensions. We've got some descriptions, and these descriptions are what you'd find in the configuration description. So I could update these to say smile to match the configuration names. We've then got a whole load of suppression states. We've then got the part number. So this is what is shown on a bill of materials. At the moment, they're all showing $D, which is document. But actually, we could choose the configuration description or the parent configuration description. So, for example, I might leave that as document, but I might choose to change these to show the configuration name. So it just pulls through the different items there. We've then got a number of user notes. Now, user note columns are just values that you want to fill in, anything you want. It's just usually columns that you're going to calculate from. And then finally, we've got color. Now, color is a calculated value based on the three previous cells, which are actually the R value, the G value, and the B value of your color. And then there's a long equation which takes the R value, the G value, and the B value and multiplies them all up to give you one massive number, which is an individual number for that color. Now, if you want to get hold of this equation, if in the SolidWorks help you look for color parameter and configurations, you'll then be able to copy it out rather than have to type it in from a dodgy video on YouTube. You'll be able to find it through the help. It's a very useful equation. One last thing is these 4 cells all need to be number cells, not text cells or generic cells. Otherwise, SolidWorks will read this value as a 0 and give you a black model, which is not very helpful. So we've got our colors there. We can also control suppression. Now, for suppression, you've got 4 possible items you can fill in, and we can see them in the drop down. So we've got suppressed, unsuppressed, S and U. S and U exactly the same as suppressed and unsuppressed respectively. They're just for people who can't be bothered to type the whole word. Now, in 2012, I could put anything into this cell and then SolidWorks would give me an error. In 13, if I tried to type something totally random into this cell, it actually gives me a warning message telling me that the value is invalid and I've got to essentially stop being an idiot, pick something off the list. So it can be it's really nice. So this error validation has been put in for a couple of different types. State is one, and the fixed value, so whether a component is fixed or floating in assembly, is another one, which I'll show you a little bit later. Now, in order to get this assembly to work, what I need to do is I need to unsuppress a couple of these items. Let's make sure I get the right ones, so that it will rebuild and you can see the changes from this yellow disk. I'm also going to attempt to change the color, and that wants to be a 0 and that wants to be 255. So we can see it calculating this value, and this is the RGB value, so with a bit of luck this should be blue. And then we're going to come out. So it updates all the configurations, and then we're going to go into them. So if we go into smile, we get the first one, and if we go into frown, we get the second one. So what we're doing is we're controlling whether these features are turned on or off by using that suppression state. Really nice way to control your different features, and you can do the same suppressing components in an assembly as well. So just be aware of that. But it's a really nice tool to be able to use. So what we're going to do now is we're going to move on and have a look at a design table for an assembly. So if we jump into this one, here's an assembly. It's just 2 gears, which I put together just to show you what it looks like. So we've got a design table. If we come in, edit the table, let's load it up in Excel. Now, in an assembly, you control assembly details. So I've got the distances for the gear mate to make sure my gears hook up, descriptions of my configurations. We've got a sketch which I'm controlling. We've then got the configurations of particular instances of parts. So this is $configuration at case instance 1. We've then got configuration at shaft instance 1 and shaft instance 2. And then we've also got the fixed for the gear instance 1, and this is the fixed item which also has the validation in it. So if I just show that, we get the error message. Now we are actually controlling the configurations of my subcomponents. So in here I've got a drop down list of the configurations that are available for case 1. So it makes your life nice and easy. You can pick what's going to be visible and what's not going to be visible. Likewise, I've got the configurations that are available for the shaft. There is actually another VLOOKUP here where we have a look at the configuration of our case, and we give it a matching shaft. So essentially it just says, right, for steel and titanium we're going to use heavy, and for magnesium we're going to use light, and that's just being picked up from this table here. So we're using the correct shafts. Now I said this is controlling a sketch. In my assembly there is a driving sketch in the background. So there's this driving sketch at the back there. Now I can't actually control part parameters directly. So what happens is we have a controlling sketch, and then that controlling sketch controls my case. So my case dimensions equal that controlling sketch dimension. So although I'm not directly driving my component, I can still resize my component based on what is said in the design table. So if I jump into this, we can, for example, take the magnesium case and we'll make it slightly taller. So rather than 125, let's choose 175 just as a number. And then when we come out of that, as we go into magnesium, we'll see that it becomes a much taller case. So I'm not controlling the part directly, but I can still control the part using driving sketches. But it's just to be aware of. In my parts, if I jump in to my case, I've got a number of configurations, which is what we're picking off. But in 2013, I can actually control the materials. So if I create a design table for this, design table auto create, just give that 2 seconds to come through, we can see here it's pulled through a number of properties. We've got description, color, and material. Now this is new in 2013. The syntax is $library : material at part name. In a multi-body part, you would have at body underscore name just to control the various bodies. And what you type in is the library name, SolidWorks materials, : and then the material name. So it's very easy. So at the moment we've got material not specified. That's fairly self-explanatory. No library on the front. We then got SolidWorks materials steel, SolidWorks materials titanium, SolidWorks materials magnesium alloy. So if I come in and have a look at my materials, if we go under magnesium alloy, if we go to edit material, we can see that this is the library, SolidWorks materials. Ignore the subfolders, and then we've got the name of the material itself, so magnesium alloy. I could equally have had custom materials : custom plastic, and that would then use the custom materials library and look for the material called custom plastic. So it's another nice new feature in 2013. Right, we're now going to have a look at some linked configurations, linked design tables, sorry. So what I'm going to do is I'm going to open up an external table, imaginally called external table. So we'll just let this load. And what I've done here is I've created a design table which can be used by non-SolidWorks users. So I might have somebody in sales who knows they want this standard part to be at a new size, and I can fill it in here. And then they can generate the configurations in SolidWorks. So this idea is I can send it to a customer for them to fill in the sizes they wanted, and then I could get it back and just regenerate all the sizes very quickly. You'll also notice I've formatted it so it looks a bit nicer, a little bit more understandable for users who aren't quite so familiar with design tables. The actual property names are hidden in this row here, so I do still need the property names, but I can hide them away. So we have default 250, 150, 50, 50, letter depth of 2, and line 1 and line 2. And I don't necessarily need to know what those properties are as long as I fill in all the cells. So let's create a new order. And we're going to have a same width plate, but we're going to make it taller. I'm then going to move the bottom row up a touch, but we'll keep the top row where it is. Same cut depth. And let's give it some values. So, typing those into the two cells. You will notice it gives you a tooltip of what the property is, but you can ignore that if you don't understand it. That's absolutely fine. I'm now going to save that table and close it. And then I'm going to open up my linked tables part. So the part wasn't open while I was editing the Excel file. Let that open up. I straight away get a warning that the linked table value has changed, and I've got two options. I can either update the model with the changes in the design table, or I can update the design table back to how it was. So usually you would choose update the model with the changes made. Hit OK. It'll then open my part with the changes I made, so it should add that additional configuration in. Give that 2 seconds to happen. So there it's loading the table, pulling the information in, generating the new configuration, and we are currently in the original one, but if I try new order, we can see first try, so it's moved everything up and looks exactly as we wanted it to. So it becomes very easy for non-SolidWorks users to open their Excel file, fill the numbers in the columns that they understand, and then either yourself or if they have access to a computer with SolidWorks on, open up the SolidWorks file, watch it rebuild and get all of those new configurations in, and then potentially open a drawing and print it. They don't need to understand how the part was actually created or the design process behind the part. It's just allow the design table to do the updating. It's a really handy tool, particularly if you want to send details to customers, etc. Now, if you are sending this file off-site, then you don't need to send the Excel file with it. It will just say I can't find it, can't get any updates, but it already keeps one of these files internally. So don't worry about that at all. Now, how did I create this linked design table? Well, it was pretty simple actually. What we did is, if I jump into my nice simple part that I started with, if I've got a design table like I have already for this part, what I do is I right click on it and choose Save Table. We're then going to say, it will then open it up and ask me where it wants to save it. So there it is, it's updating it, making sure it's up to date. And then it's going to ask where I want to save that file. So I'm going to save that under New Design Table, and we'll hit Save. Now what I've got is I've got a design table Excel file which is completely independent from SolidWorks, which is still using the internal one. So in order to link them together, what I need to do is delete the one that's in there out, and then I want to insert a design table, and this time I'm going to choose from File. I'm then going to choose Browse and go and find it, New Design Table, and I'm going to choose to link them. If I don't link them, it drags all the information in and then ignores the Excel file that's saved away. If I do link them, then edits go backwards and forwards. And what it's doing is it's going to open that Excel file up, drag the information in and create the Excel file within SolidWorks. So just give that a couple of seconds to happen. So there we go, that's my design table that's been created, and there's been a link created between the two, and we can see the various different items there. And if I come out of that, there we go, and we've now got those and they're linked back together. So it's very simple. You create it in SolidWorks, you then save it out, delete it in SolidWorks because you've got the information, and then link the two back together again. Thank you very much for watching. We've got some future webinars coming up. We've got the 22nd of November, Advanced Surfacing. 29th of November, we've got routing and piping set up in SolidWorks. 6th of, that should say December, that's careless of me, piping routes in SolidWorks. Now I mentioned that you might want to check out some videos on the configure feature tables. The video names you want to have a look at on our website are Introduction to Configurations, and also there's another video which is a snippet video which is configure feature. And as always, if you've got any questions, do feel free to email us or ring us on the number below, and we'd be most happy to help you. Thank you very much for watching.